Okay, so for the chapter 1 homework, the first homework is 1.1.12. So this problem asks us to calculate the amount that we should pay to pay off the total credit card debt, 12, uh, 112,000 without new purchase in the next 2 or 4 years with the given APR. So first we need to calculate the interest rate based by months. So and then uh, we need to find the total amount, the amount of money that we should pay each month. So we have so for the remaining balance at month's end, we have it's equals to the remaining balance of the month equals to n minus 1 times the 1 plus the monthly rate. So that would be the last month's remaining times the monthly rate and minus the monthly payment. So this would be the new amount of balance we need to pay this month. So we have this equation. We can do like first 3 months, A1, A2, and A3. Then we substitute all the A2 and A1 into the A3. So we can get A3 is equals to whatever's A0 is, the initial amount, times the interest rate by 3 times, and then it has a monthly pay minus monthly payment times 1 plus interest rate square and 1 plus interest rate and plus 1. So we can get a generic form of the monthly remaining balance of AN, and then we can simplify the right part of the this one, and we can, since it's a geometric progression, so we can simplify that to this equation. As we know, the A24, which is the last amount, since we need to pay off the total amount by 24 months, so the A24 should equal to 0, and A0 is the initial amount, and then we can get the equation which can calculate to the monthly payment. Then we substitute the A0 and the interest rate into our equation, and we can get our monthly payment of 6, 10, and 16 if we want to pay off in 2 years. And if we want to pay off in 4 years, we can, and the amount is $364.5. So we put that equation into a function here, and we plot the graph using using a range of the months is 24 to 48, and we plot here, and it can shows that if we make more money, like more money each month, we will pay off quickly, and if we make less money each month, pay less money each month, then the slope will continue to gain longer and longer as we pay less and less. So this is question 1.1.12. The second one is pretty straightforward. It is like the third example in the book, I guess. This one asks us to calculate a dynamic model to find the change of infected people. So the total population we set to n, and the proportion of initial infected people we set to I0, and we can set the k variable to be the proportion of people who will be infected after interaction. So we can get this number is the number of people who are not infected after an amount of time, and it times I n represents the number of possible interactions, and times k, it will be the number of newly infected people. So we can get the in plus 1 equals to in plus the kin times n minus in. If we are given our I0 and the k, we can easily get the in by this function. The third problem is 1.3.6. So it shows that we owe $500 to the credit card bank, and the monthly interest is 1.5%. The problem asks us to find the equilibrium. So we can find the equation from the book, that is A equals to B over 1 minus R. So we can easily know that the B, which is the amount we should pay, we're going to pay each month, that is $50. So B equals to minus 50, and the interest rate is given. So we can get our equilibrium. A equals to 10,000 over 3. In terms of the credit card problem, the equilibrium means that if we owe this amount of dollars to the credit card company, and we pay a monthly payment of $50 as usual, and the monthly interest stays 1.5%, and the credit card balance won't change anymore. It will stays the initial amount, which is 10,000 over 3. So since the R is larger than 1, the equilibrium is unstable. So based on the theorem 3, we can get the equation of this one, and then we need to calculate the constant C based on the A0. So we plug in the number, and 500 equals to 3 plus 10,000 over 3. So we can get the constant C here, and we can plug in the constant here. We can get an equation, and then I define a function of this equation, and I plug in the x and it's from 0 to 15 months. So it asks us to find out how many months we can pay off the $500 if we pay $50 each month. So we can get the money remaining in the Y list here, and we can say that on the 11th, on 10th, this is the initial amount. So it's on the 10th month, we are left at $45. So it need us for 11 months to pay the debt off, and the last payment will be the $45. And the graph is here. We can say that when the balance is 0, it's roughly 11 months. So the last questions ask is about the SIR model. It asks to change some parameters from the given model in the book. So the first parameter we're going to change is the initial affected population, and the number of populations infected in the second week. So this is a mistype. The initial the factor we're going to change is I believe is the population that is infected at the second week. So in the start population still 1,000, and the I0 is equal to 5, and the S0, so it's 1,000 minus 5. we still have like 5 or 3 weeks to recover. So it's still 60% of infected people will be removed each week. So as we plug in the numbers, we can get an A of 0.002613, and then we plug in we can get the SIR model here. So the second part, it lasts for 1 week. So it means like 100% of infected will be removed each week. So we can, so the A here, so the A here would be changed to 0.001809 based on the calculation here. And we can get our models here. And the C part is quite similar to the B part. The only difference it is lasts for 4 weeks. So the parameter here will become 0.25. So this model will become this one, and the constant A will decrease compared to the previous one. The last one, it changed the total population to 4,000, and it five affected initially and 30 affected the next week. So as previous, we also plug in the numbers. The 0.6 stays the same since it also need a 5 or 3 weeks to recover. So we can get our models here, and I define a SIR function here. As I plug in the numbers of the 4 different situations, and the graph is shown in my work. So each graph, since it has different beta and mega numbers, the graph will look slightly different for the S value, IR value, and R value. So this is my work for the first week. How to